Let's review this idea of subnetting. We'll do this by looking first of all at what we already know. When data packets come in from the internet, our router will examine our IP address, be able to identify the network ID from the host ID, and then forward the data packets to the particular host on the network, in other words, the device on the LAN that was expecting those data packets. So with this in mind, let's remind ourselves of the idea of IP addresses and subnet masks. We have here a private Class C IP address at the top, 192.168.1.32. Because this is a Class C private IP address, I know that the first three denary integers on the left represent the network ID, or the LAN, with the final integer representing the device on that LAN, or the host ID. The router can't distinguish these two components on its own. This is where the subnet mask comes into play. The subnet mask is going to be 255 or 0 for each of the four denary integers in our IPv4 address. As you can see by looking at the pattern here, if the denary integer is part of the network ID, the subnet mask's integers will be 255. In this case there are three of them because, as I've said before, the top IP address here is a Class C address. If it was a Class A address, only the first integer would be 255 in the subnet mask, and if it was Class B, the first two integers in the subnet mask would be 255. You can also see that in the subnet mask where the integer is 0, that means that's correlating to the host ID in the original IPv4 address. So the router needs the subnet mask to identify the difference between the network ID and the host ID, splitting that IPv4 address in doing so. So what does all this have to do with subnetting? Well, as we've looked at other things like classless interdomain routing, or CIDR, network address translation, or NAT, subnetting is another way of organizing networks. In particular, subnetting means we break a large LAN into two or more smaller networks, known as subnetworks, or simply subnets for short. So the data packets come into the router. We may now actually end up with more than one router, but regardless, the router still requires the split between the network ID and the host ID using the subnet mask. And then, once we've got that established, the data packets can be moved onto one or more subnets. So why do we use subnetting? Well, there's two main reasons. The first is by splitting a large local area network into a series of smaller local area networks, or subnets within the one big LAN, I should say, we can actually increase network performance. If we've got smaller subnets on the one LAN, that means different people are allocated to different subnets. A teacher subnet, a student subnet, an administration subnet in a school, for example. Increased performance is due to the fact that we're going to have less congestion on each of those subnets compared to if everyone was on the same network. The second reason why we might choose to subnet a network is increased security. If we've got this idea, we've got a teacher network, a student network, and an administration network, or subnet, we can actually ensure that students, for example, can't access teacher payroll data on the admin network, and teachers can't access maybe some more confidential information about students that administration needs to know but has no relevance for teaching and learning. And we see this with this diagram. The first part is what we had with say, network address translation, for example. We've got an IP address that is comprised of two components, the network ID and the host ID. The network tells the router what LAN that it needs the packets to go to, and the host ID tells the router which device on that LAN to send the packets to. But with subnetting, we still have the idea of a network ID and a host ID, but we also have to add in this subnet identifier. So we can't take bits away from the network ID, otherwise the router won't think that the packet that's arrived is actually for that local area network. So instead, we actually take some of the bits that were originally given to the host ID, maybe 1, 2, 3 bits, depending on how many subnets and users we have. And these bits that are taken from the host ID are used for the subnet ID. The subnet ID and the network ID now work together to identify the LAN and then its subnetwork on that LAN, and yet we still have a separate host ID identifying the individual device on a particular subnet within the wider LAN.